Netflix, WhatsApp, your online banking, they look completely different, but underneath they all fall into one of four patterns, and once you see it, you can't unsee it. It changes how you think about every app you'll ever build, and then you'll be able to build apps yourself. Hi, my name is Aaron. I'm a professional software developer for over 30 years now. In this video, we are covering four patterns: the desktop, the CGI, the SPA, and the real-time. By the end, when an AI tool builds you an app, you will actually know what kind of app to build, and you'll be able to make a conscious choice about it. One honest promise: no code, just the thinking behind it, explained by someone who lived through all four. I've been building apps since before the web existed. I've built things in all four of these architectures. So this isn't theory. It's pattern recognition from 30 years of watching this evolve. These patterns didn't just pop out of nowhere. They were dictated by the possibilities and evolved over time. So now I'll take you to a time travel. First, the desktop era, when everything lived on your computer. Every app was a self-contained box on your machine. Clicking a button in Excel immediately ran Excel code. No network, no waiting. The key insight, the UI, was the app. They were inseparable, like the TV controls built into a TV set. The reason it worked is it was fast, reliable, and there was no internet dependency. But everybody needed their own copy. Sharing data meant floppy disks and then later CD-ROMs. Updating the app meant sending everyone a new disk. This still lives on though. Nowadays, all computer games work exactly this way. Why? Because the network isn't fast enough to transmit beautiful high-resolution images 60 or 120 times per second, which is completely an expectation from players though. To better understand this era, imagine if every employee in a company had their own private library, and every time you updated a book, you had to walk around and swap every copy by hand. That's what software distribution looked like. Second came the CGI era, when the apps moved to the servers. The big idea was, what if the app lived on one computer, a big one, and everyone connected to it remotely? This posed a new problem. How do you show a UI to someone across the network? You needed a shared language that any computer can understand. That language became HTML. It doesn't run anything, it just describes what a screen should look like, universally. Think of HTML as a blueprint. The server draws the blueprint, sends it across the network, and your browser builds the room from the blueprint. This was CGI, the Common Gateway Interface. When you click a button, your browser sends a request to the server runs the app, generates a fresh HTML page, and sends it back. You see a new page. I remember building CGI apps in the mid-90s. The speed was painful compared to desktop apps, but the distribution problem was completely solved. One update on the server and every user had it instantly. This came, however, with a trade-off. Every single click meant a full page reload. Header, footer, menu, side panel, every single one. The server was doing all the work. Imagine it kind of like ordering at a restaurant where the waiter disappears, the kitchen rebuilds the entire dining room and then lets you back in, just because you asked for ketchup. Then came the SPA era, when only the data traveled. As networks became faster and browsers smarter, new features arrived. Along came style sheets, commonly called CSS, and made HTML look decent. But JavaScript was the real game changer. JavaScript is a programming language that runs inside the browser. For the first time, the browser could do things without asking the server first. Then came the big realization. We were reloading entire pages just to change one small thing, like a new chat message, an updated price, or notification badge. Why send a 200-line HTML page when all you need is the number 42? A technology called Ajax changed everything. Instead of asking the server for a whole new page, you just ask for the data. The browser updates only the piece that changed, and the knowledge on displaying the data moved to the browser, thus separating the user interface part of the app from the business logic. This gave us single-page applications, SPAs. The whole outer shell of the app loads once. After that, only data flows back and forth as JSON, which is a simple but structured way of containing data. Real-world examples include Gmail, Google Maps, Facebook, Instagram. They all load once and then feel instant. There are tools that enable this like React, Angular, and Vue. These are frameworks that manage which part of the screen updates and when. They all have different philosophies, but they all accomplish the same. This is basically what every serious web app uses today. When you build something with bold.new or cursor and it just works without page reloads, this is why. But the trade-off is more complexity. The browser is now doing a lot of heavy lifting, and if JavaScript breaks, nothing works. Also, you now have two components, the server and the browser, which use different technologies, so they are more difficult to learn. Keeping up with the kitchen example, in this era, if the daily soup changes, instead of reprinting the entire menu, the waiter just leans over and whispers you what the new soup is. That's Ajax. We arrived to today, the WebSocket era. Real-time, two-way communication. The basic principle of the web is fundamentally request-response. You ask, the server answers. If you want an update, you have to keep asking. The problem: what if the server needs to tell you something right now, like a new chat message, live stock price, a collaborator moving their cursor in a Google Doc? Our old workaround was called polling. Ask the server every second. Anything new? Anything new? Anything new? It's wasteful, it's slow, and it puts enormous load on the server. WebSocket solves this. Instead of constantly opening and closing a connection, you open one persistent, bidirectional connection and keep it open. Server and client can now talk to each other at any time from either direction. The analogy: going from sending letters back and forth, which was HTTP, to having a phone call, which is WebSocket. The line stays open, either side can speak. What this powers today is live chat, voice calls, ChatGPT's typing-like interface, real-time collaboration, live stock tickers, multiplayer games, real-time notifications, anything where waiting 1 second is just too long. WebSocket felt like magic the first time I used it. After decades of request response, having the server just talk to you unprompted, it was genuinely strange, but in the best possible way. Of course, there's a trade-off: more complex infrastructure. The server has to maintain thousands of open connections simultaneously. That's engineering overhead, which is why most non-coders shouldn't build this from scratch. Use a platform that handles it, like Firebase, Supabase, or Pusher. We'll talk about those in later videos. Let's recap. A desktop app means the app lives on your computer, fast but locked down. A CGI app means the app moves to a server. HTML becomes the universal screen language. An SPA app means only data travels. The browser does more of the work. A WebSocket-based SPA app is one of permanent open line, real-time, two-way, no waiting, but it's still an SPA. These aren't just history. Every app you will build with AI today falls into one of these categories. Bolt.new defaults to an SPA. Firebase gives you WebSockets. Knowing which architecture your app uses and why is the difference between a builder who understands their tool and one who is just guessing and praying. You didn't need to know how to code to follow any of that. And you don't need to code to make the right architectural choice. You just need to know what problem you are solving. If this kind of thinking is useful to you, the why behind the how, then you'll want to subscribe to Aaron Vitwise Weekly. Every week I pick one concept like this, something that took me years to fully understand, and explain it in 5 minutes. No padding, no hype, just the thing that actually matters. Link is in the description. I'll see you there. Bye bye.